Hello students, my name is Shashank Shekhar. So we will start the exercise of chapter Aldehyde Ketone and Carboxylic acid. The first question says that what is meant by the following terms? Give an example of the reaction. Give an example of the reaction in each case. Okay, so we have to give the example of reaction in each case. How we'll do it? First is cyanohydrine, second is acetal, third is semicarbazone, and fourth is aldol. Okay, so we have to do for each of it. Then we have hemiacetal, oxime, ketal, imine, 2,4-dinitroderivative and Skipp's base. First one is cyanohydrine. So cyanohydrine are what? So they are organic compound which have the formula of ROHCN. Okay. So you can see that we have carbon here and CN attached to this, and the same carbon has a OH bond. Okay, the same carbon has a OH bond. Now next what will happen? How do we do the reaction of this? So for that we will have a ketone, and then ketone will reacted with HCN, right? So when ketone reacts with HCN, CN attacks here, HCN and NaCN, and CN minus of this Na, okay, CN minus of this Na acts as the nucleophile, whereas this HCN is there for protonation. Okay, so NaCN, CN minus is for the nucleophilic attack, and HCN is here for the protonation. Why protonation? So as soon we get this RCOH, CN minus will attack here. This will remove the pi bond on the oxygen. R, it is R dash. This is CN, and this is R dash. Okay. Now this is further protonated by the HCNH. Clear? So in this way we can synthesize cyanohydrine. Next is acetal. So what are acetal? So acetal are gem dialkoxyalkane. Means gem dialkoxyalkane means there are two alkoxy group. Okay, there are two alkoxy group on the same carbon, because gem is written, in which the two alkoxy group are present on the terminal carbon atom. Okay, both are present on the terminal carbon atom. One bond is connected to an alkyl group, while the other is connected to a hydrogen atom. So we'll see the structure. So this is the structure. Okay, this is the structure. How does it happen? So we treat the aldehyde. So when we treat the aldehyde with any alcohol, that will result in this kind of structure. See, ROH. So what happens here? So we have this. Okay, so we have this. This is the terminal carbonyl center. This is aldehyde. First of all, this R-O, that is our alcohol. This will attack. So this will attack here. This bond will move on the upside. O with a negative sign. O R dash and H. Okay. Now further, we have introduced HCl also. You can see dry HCl gas is passed. So this will just protonate this. Or else you can use the H of RSOH also. So it will be protonated in this way. Why is this HCl used here? So for the facility of you can say that making the attack of ROH group more easier, right? So here the lone pair will attack. This lone pair will attack. Clear? Now next we will introduce H plus and ROH again. This H plus will protonate this OH group. So this will be protonated. OH2 plus will be formed. Okay. And in the next step, what will happen? OR dash will attack. Okay, this OR dash will attack. And this will be removed. So this is called as acetal. It is called as acetal. Next we have semi-carbazone. So what is semi-carbazone? So again, it is a derivative of aldehyde and ketone, and it is formed by the condensation reaction between a ketone or a aldehyde. See, this is the example. So this is semi-carbazide, that is NH2, NHCO, NH2. So what happens? So this N attacks here on the carbonyl center, and that results in this adduct. Further, this OH is removed and we get this semi-carbazone. So how does this reaction proceeds? So we have N, H2, NH, CO, NH2. R, R dash. Now this lone pair will attack here. This bond pair will move upside. O negative, NH2 with a positive sign, and this is NH and CO, NH2. Clear? Now next, the interproton transfer will take place. Further, first it will be protonated, okay, and then it will be pushed by nitrogen. Okay, so that will finally result in this kind of okay, this is called as semi-carbazone. Next we have aldol. So aldol is what? So it is the formation of beta hydroxyaldehyde, okay, with the help of aldehyde or ketone, and 2 moles of that aldehyde or ketone are taken such that there is an alpha carbon present. So this results in condensation product, and this is called as aldol reaction. So aldol reaction, how does aldol reaction takes place? So we have this, suppose aldehyde, right? We have this aldehyde. Suppose this is R, right? Now next what will happen? The base we have here, this will just deprotonate this and result in this kind of formation. H. Okay. Now we have another molecule of the same compound. See, we have another molecule of the same compound. Now this will just come down and it will attack here. This will go up. So that would result in R, TH, O, H, and this will be joined here, OH, CH2, R, right? And here we have one more H. So this is alpha, this is beta. At beta position we have hydroxy. So beta hydroxy ketone or aldehyde. Okay. Next is hemiacetal. What is hemiacetal? So hemiacetal is nothing but the first product that we get upon reaction with alcohol. We do not do the further attack. Okay, so here in the first step, the thing that is formed, it is called as hemiacetal. We have seen this. Next is oxime. What are oximes? So oximes are a class of organic compound having the general formula R-CNO. What it is? R-CNOH. So this one looks like this. See? R-CNOH. This is aldoxime and this is ketoxime. So on treatment with hydroxylamine, So hydroxylamide on treatment with in a weakly acidic medium, aldehyde or ketone results in the formation of keto or aldoxime. This NH2OH, this is your hydroxyl enzyme. So this lone pair attacks your aldehyde and ketone and results in this formation. See, so how does this reaction would have happened? So we have our oxime here, right? This is our oxime. This is lone pair. It will attack here, and this will push it here. Now interproton transfer will take place. I am doing it in the same step. Okay. Now again this will push here because it is in the acidic medium. It will be protonated and removed. See? Okay. Next is ketal. So we have ketal, we have seen. I think it is repeated twice. Sorry for this. No, ketal is different, right? Ketal is different. So in case of ketal, what do we do? Rather than two alcohol, okay, we take a single alcohol having two aldehyde group. Now a hydroxyl group. Now this both hydroxyl group will slowly substitute both of the double bonds, and that will result in formation of this ketal. Next is imine. What is imine? So when R1, this carbon is bonded to a double bond N, then this is called as amine. How it is formed? So on treatment with a derivative of ammonia, suppose I am taking R here, right? I am taking R here, and we treat it with aldehyde. So similarly, this will attack here on the center, and that will result in imine. So this is our imine. Next, what do we have? 2,4-dinitrophenylhydrazone. 2,4-dinitrophenylhydrazone. So this is our 2,4-dinitrophenylhydrazine. Okay, so when we treat it with CO, so that will result in 2,4-dinitrophenylhydrazone. Okay, clear? This is hydrazine when we have NH2, and when it is treated with this carbonyl, we get hydrazone. To identify and characterize aldehyde and ketone, 2,4-DNP is used. So this reagent is used for the identification of this group. Next we have Skiff's base. So Skiff's base is a chemical compound, a carbon containing double bond with a nitrogen or alkyl group but not hydrogen. So this is the general formula of Skiff's base. So it is named after the scientist Hugo Skiff. So it is basically a amine, right? So again, this is produced by the same method. Okay. Next question. So what we have to do? We have to name the following compound according to IUPAC name nomenclature. So the first compound is this 4-methylpentanol. So how do we name it? CH3, CH, CH3, CH2, CH3, CH, CH3, CH2. Then what we have? CH2, CHO. Okay. CH2, CHO. Okay. So just expand this. It will make a more clear picture. So I'm writing the bond line structure. Okay. I'm writing the bond line structure. One carbon here, one carbon here. And then we have CHO. So this is the bond line structure. Just try to name it. How we'll name it? So at first position we have aldehyde group. Aldehyde group is always at first position only. So how many carbons are maximum? 1, 2, 3, 4 and 5. And at 2 position we have methyl. So 2-methyl pentanol. 2-methyl pentanol. Okay. Next we have, if we just draw this, so this is CH3, CH2CO, CH3, CH2CO, then CH, C2H5, CH2, CH2Cl. Okay, let's just expand this. So one CH3, then CH2, then CO, then again one CH. This is bonded with a ethyl group. Okay, then we have CH2, then CH2, and then Cl. So this is the bond line structure. So how I will name it? Okay, just try to name this. Okay, so this name will come out to be 6-chloro. Okay, so this is 1, 2, 3, 4, 5, and 6. So out of these two, we have taken this one. Why? Because in this we have a functional group. So at 6th position we have chloro, 6-chloro. Then at 3rd position we have what? Our ketone. And at 4th position we have ethyl. So 4-ethyl. How many carbons? 6 carbons. So hex, hexane on. At 3rd position we have on. Clear? Next is CH3, CH, CH, CHO. CH3, CH, CH, CHO. Let us just expand this thing. Double bond, CH, and then CHO. 1, 2. Okay, so we'll start the numbering from here. 1, 2, 3, 4, 5. So that would be at 3rd position we have alkene. So I would name it. Okay. So its name would be but 2 in 1 ul. Okay, but 2 in 1 ul. How? So at 1st position we have aldehyde, and 4 carbons are there, I think. So 1, 2, 3, 4 carbons. So I've just named it one more. Okay. Yes. Now it is good. So 1, 2, 3, and 4. So butane, 2 in and 1 ul. Next is CH3CO, CH2CO. CH3CO, CH2CO, and again CH3, right? So how we'll expand this? In this way. If you just try to name this, 1, 2, 3, 4, 5. Pent 2,4 dione. Okay, pentane 2,4 dione. Okay, next question. So next question is CH3, CH, CH3. CH3, CH, CH3, CH2C, CH2C, CH3 whole twice, COCH3. So if we just expand this, we have CH3 here, this CH3 here, CH2 here, 2 CH3s here, and one more CO, and then CH3. So this is the complete structure. If I name it from here, 1, 2, 3, 4, 5, and 6. So at 3 and 5 position we have methyl. So 3, 3, 5, trimethyl hex, hexane, what? Hexane 2-on. Okay, hexane 2-on. Next is what? Next is CH3 whole thrice, C, CH2 COOH. Again we will expand this. One, 2, 3 and 4. So but at 3 position, dimethyl butanoic acid. Clear? Next, CHO C6H4, CHOP. So here we have a benzene. What? We have a benzene here. And at para position, so here we have a CHO and here we have a CHO. So how we will name it? Say, so this will be benzene 1,2,1,4-dicarbonyl. Okay, benzene 1,4-dicarbonyl. So since there are two CHO, if it was one CHO, then we would simply name it benzaldehyde. Okay, benzaldehyde. But since there are two aldehyde groups, so we have named it benzene 1,2-dicarbonyl. Next, we have to draw the structure of the following compound. The first is 3-methyl-butanol. 3-methyl-butanol. So 4 carbons are there. Okay, 4 carbons are there. At 3 position we have methyl, and at first position we have aldehyde. 1, 2, 3, 4. Okay, so this is the structure. Next is para-nitropropionone. Okay, para-nitropropionone. So this will be in this way. Okay, so how I will name it? That nitro, para will be nitro here. Propionone will be in which way? So this will be propionone, right? See, this will be propionone. So propane, and this is phenone group with a para-nitro position. Next we have para-methyl-benzaldehyde. Para-methyl-benzaldehyde. So first we will draw the benzaldehyde, and at para position we have methyl. Okay. Next is 4-methyl-pentane 3-in-2-one. 4-methyl-pentane pent 3-in-2-one. 2-one. So at first we will draw pentane. Then at 3 position, suppose this is 1. Okay. At 3 position, 1, 2, 3, we have a double bond. And at 2 position, we have a ketone. And at 4th position, 1, 2, 3, 4. 1, 2, 3, so 5. Okay, 5 carbon should be there. At 4th position, we have a methyl. Okay, so this is the structure. Next is 4-chloropentane 2-one. 4-chloropentane 2-one. So 1, 2, 3, 4, 5. 1, 2, 3, 4. We have chloro, and 2 position we have ketone. Next is 3-bromo 4-phenyl pentanoic acid. 3-bromo 4-phenyl pentanoic acid. 3-bromo 4-phenyl pentanoic acid. 5 carbons, 1, 2, 3, 4, 5, and this is COOH. Okay, at 3 position we have bromine, and at 4th position we have phenyl. Clear? Next is para hydroxy dihydroxy benzophenone. Dihydroxy benzophenone. So it means that 2 carbons are joined by hydroxy group. Oh, okay. 2 carbons are joined by O. And at both para position we have OH. So this is the structure. Okay, so we have a carbon also. Here we have a carbon. Okay, we have a carbon. So this is the structure. Sorry for that. That was wrong one. This is the structure. Last we have hex 2 in 4 ionoic acid. 1, 2, 3, 4. 1, 2, 3, 4. 2 position we have ene, and at 4 position we have carboxylic acid. Okay. Now let us see the solutions, right? These are solutions. You can just pause the video and see. Okay, now next question. So I think we have done this now. So this is the 4th question. Okay, so how we'll do it?